still another quick catch-up mini lecture um, about, well, in our section about matrices. We're still in here. But we have said this quickly, but I want to come back to this. Is there any connection between all of this talk about matrices and vectors and so on? Is there a connection between this and what our goal was last week, which was solving linear systems systematically? So by now we definitely know that yes, there is, but we'll have a look at an example to show us why. So I'm starting off with a linear system. You've seen this 1,000 times. 1,000 times, yeah. I've taken one in x, y, z, 3 equations, 3 variables, and it looks like this. I've just picked one at random. And what I will do is try and write this down. Exactly the same information, right? I've got 3 pieces of information in the shape of 3 equations. I can write exactly the same information, but in matrix form, using matrices. So I will need to define different things. Let me do this right now. I'm defining 2 vectors and a matrix. I'm just defining them. I'm saying this. Okay, B is a column vector. It holds these guys here. It holds this. Okay? I should take this funny pen I have. The magic pen. It holds this information. B holds this. X is a column vector made up of the actual variables. I'm just saying this. This is a definition. And then I've made up a matrix that, as you can see, has these numbers here, the coefficients of the variables and the equations. It's just a matrix that's made up like that. Okay, I've defined that. Let's see what else I can do. Okay, let's see if it's possible to write down mx equals b and see what happens. Let's see if this is actually equivalent to our system. I'm kind of saying, well, yes, it's going to be. So let's just see why. mx. What's mx? Okay, this is mx. I should probably write this. mx is equal to that. I've rewritten m. This is x. And you definitely know how to do this. Matrix multiplication. 3 times x plus 2 times y minus z minus 1 times z, first entry. And then I carry on 0x plus 3y's plus 7z, second entry, 9x minus 1y minus 11z, third entry. So I started off with a 3 by 3 matrix, m is 3 by 3, times my vector x, which was what, a 3 by 1? Oh, quick. And that gives me a certain vector, undefined, but it's, let's call it u. It's a 3 by 1. Should come as no surprise. This is u and it's a 3 by 1. Okay, so I've written that. So if I was to say mx, this guy here, is equal to b. What was b again? Well, it was the right hand side here. It was a vector made up of these guys. This is b. I found mx. So what if I write mx equals b? It means that, right? This is mx. This is this guy up here. This is this. Well, this is this. This whole vector is this whole vector. And I've just said, let me say it's equal to b and see what happens. Okay, so I've got here 2 matrices, or actually 2 vectors, 2 3 by 1 vectors. What does it mean for them to be equal? Well, it means they have to be of the same size. If you go back to your definition of being equal, they're of the same size, which they are. They both are 3 by 1. And it means that each entry is equal to its corresponding entry. So the 1, 1 entry is equal to the 1, 1 entry here. And then the second entry is equal to that one, and then that one is equal to that one. So that's what it means. Usually we leave it at that, but let's just write down what this means. It means that the first entry is equal to the first entry, so I can write this like that. This is equal to that. This is what it means, yeah? It's basically 3 statements in one. We don't often think of it like that, but we could do. So I've just rewritten the 3 statements. And look at this. This is precisely what we started off with. So it's just a rewriting. We've not solved anything. Actually, we've done nothing. But we've rewritten the same information in matrix form. I've just, let's say, expanded it all. But once I've defined these guys, instead of writing the full system, I can just write, let's define B, X, and M. And I'm telling you that, well, we have this. This is true. This is completely equivalent to writing all that. That's it.